All right, let's dive into a classic GCSE maths question. But you know what? We're not going to treat this like some boring old exam problem. Nope. Think of it more like a puzzle, a code that we're going to crack together. Sound good? Okay, first things first. See that little symbol? That tells you this is from a non-calculator paper. That's right, no safety net here. But honestly, that's what makes it fun. We're going to solve this thing with nothing but our own brain power. So what exactly is this puzzle we've got to solve? Let's pull up the exact question from the paper and take a look. And here it is. We're given a sequence of numbers, 1, 5, 9, 13. Our job is to find an expression in terms of n for the nth term of this sequence. Basically, we need to find the rule that makes this pattern tick. Now, the question throws out a key phrase here, arithmetic sequence. Don't let the fancy words fool you. All it means is that the numbers go up or down by the exact same amount every single time. It's got this constant, predictable jump. And let me tell you, that is a massive clue for us. All right, time to put on our detective hats. First step, we need to find that jump between the numbers, what mathematicians call the common difference. We're going to start by just looking for the most obvious pattern. So take a look at the sequence. How are we getting from 1 to 5, and then from 5 to 9, and you guessed it, from 9 to 13? What's going on here? What's the link? Aha! And there it is. You see it, right? Each number is jumping up by 4. It's a constant, a predictable +4 every single time. And just like that, we found the first piece of our code. So let's lock in on that number, 4. This number is everything. It's the key that's going to unlock this whole thing. It tells us something super important about what this sequence really is. So let's hold that thought and that number in our minds. Okay, get ready for the aha moment. This is where it all starts to click. We're going to take our big clue, that number 4, and use a neat little trick. And it involves something you definitely already know, your times tables. All right, check this out. This is where we're going to make a really important comparison. See the column in the middle? That's our sequence. Now, because that jump we found was 4, it makes sense to compare it to, you guessed it, the 4 times table. And that's what you see in the column on the right. Okay, look really closely at those two columns now, the 4 times table and our sequence. How do you get from 4 down to 1? From 8 to 5? From 12 to 9? Come on, there's another pattern hiding there in plain sight. What is it? Did you get it? Every single number in our sequence is exactly 3 less than the one next to it in the 4 times table. 4 minus 3 is 1. 8 minus 3 is 5. It works every time. And that's the final piece of our puzzle. Okay, let's recap. We have our two big clues, the number 4 from the jump and the number -3 from our comparison. Now, it's time to put them together and build our final answer. And honestly, it's a super simple 2-step process. That jump of 4, that gives us the first part of our answer, 4n. That's just the fancy math way of saying the 4 times table. And then we just tack on that adjustment we found, which was -3. And boom, there you have it. The code is officially cracked. The expression for the nth term of this sequence is simply 4n minus 3. That right there is the full marks answer the exam's looking for. You know, it's always a good idea to do a quick check, just to be sure. So let's test it out. For the very first term, n would be 1. So we plug that into our new formula. 4 times 1 is 4. Take away 3 is 1. And what was the first number in our sequence? It was 1. It works. Perfect. So let's boil this all down into a simple, repeatable method you can use every time. Step 1, find the jump between the numbers. Step 2, that jump tells you which times table you're working with. So a jump of 4 means you start with 4n. And step 3, compare your sequence to that times table and figure out the adjustment. Are you adding a bit or taking a bit away? That's the whole process right there. And just like that, we're at the end. But now you have the method, you have the secret code. So here's a little challenge for you. Can you take what you've just learned and apply it to this new sequence on the screen? Give it a shot. See if you can find the nth term for this one.